Hello Geometry Honors, it's Mr. Zabo. Today in this video we are going to talk about reciprocal relationships between our trig functions. The three primary trig functions that we've studied so far are the sine, cosine, and tangent functions. And what we've studied about them is that the sine of an angle is always equal to a ratio of the lengths of the side opposite in a right triangle, or divided by the hypotenuse of that right triangle. And then our cosine is the adjacent side length divided by the hypotenuse length, and tangent is the opposite side length divided by the adjacent side length. Those are the three primary functions we've dealt with and we've studied, and this has all been dealing with it within right triangles. The reciprocal relationships are very similar, and they're exactly that. They are the reciprocals. What gets tricky is students see sine and they think that that will attach to secant. So just to what words we use for these, CSC is cosecant, SEC is secant, and COT is cotangent. Sine maps to, or is the reciprocal of, the cosecant. So instead of sine of x being the opposite over the hypotenuse, the cosecant of x is equal to the hypotenuse over the opposite. I take the reciprocal. Okay. And then I can do the same for cosine mapping to the secant, and tangent mapping to the cotangent. So these are the relationships that exist here. In other words, we would say that the sine of an angle x is equal to 1 divided by the cosecant of that angle x, or the cosecant of angle x is equal to 1 divided by the sine of angle x. And then those relationships carry through with cosine and tangent and their reciprocal functions as well. And those values look like this. So there are two things that we are going to ask you to do with regard to these reciprocal functions. First is just to be able to determine the value of these reciprocal functions. Just like we were determining the value of the cosine of an angle, we want to determine the value of the secant of an angle. And so we can do that by using our relationships as we know. Now, if we give you triangles like this, like triangle DEF or triangle ABC, and we don't give you side lengths, these are special right triangles. So keep in mind that no matter what these side lengths are, I could just do something like this, call that x, then this is x, and then this is x root 2. I know my side lengths. I could call this y, this is then 2y, and this is y times the square root of 3. I can use variables. I can just call them all. I can pick any value. Instead of doing x's and y's, I could just say that has a length of 1, that has a length of 1, that has a length of 1 square root 2. It's going to get me the same ratio. All right, so I'm going to choose just to use a unit length of 1 for each of these. And that gives me these side lengths. Again, if we did variables, we're going to get the same thing. Now, cosine of angle F is the things that we've been doing. Cosine, we know, is going to be the adjacent side divided by the hypotenuse. Angle F as my reference angle is here. Adjacent is a side length of 1. And hypotenuse is a side length of the square root of 2. We must always rationalize our denominator. When we rationalize this denominator, we get square root 2 over 2. So the cosine of angle F is square root 2 over 2. I'm going to skip to number 8. We treat the secant function the same way, it just has a different relationship. If I want the secant of angle B, so now my reference angle turns to here, I recognize that the secant is the reciprocal of the cosine. So those are the things that I have to process. And I know the cosine is adjacent over hypotenuse, so the secant is the hypotenuse divided by the adjacent. So the hypotenuse in triangle ABC has a length of 2, and the adjacent to B has a length of 1. Well, that doesn't have to be simplified. It doesn't have to be rationalized. The secant of angle B is 2. Go ahead and hit pause. I want you to try the other 4 problems here, please. And then go ahead and check your work. Again, I wrote out my ratios underneath just to kind of refresh my memory to help you see where I came up with my solutions. Now, there is one other type of question that will appear in your trig packet, but it's not on this note sheet, and I wanted to give you at least one example of that. So why don't you go ahead at the bottom of these notes, write this problem down. And we're going to talk about how we might approach this. So for a problem like this, I want us to recall that right now we are only dealing with right triangles. And this sine of x is equal to 0.3907 is telling me that one of my acute angles I can just label as x. Let's say I label this x. Sine is opposite over hypotenuse. I don't have to make this a fraction. I can just consider that as a fraction over 1, which makes this my side opposite. This side is 0.3907, and my hypotenuse has a length of 1. And now, the cosecant function, we know that that is the reciprocal of the sine function. So if the sine function is opposite over hypotenuse, the cosecant function is hypotenuse over opposite. This is going to be equal to 1 over 0.3907, which means it's equal to approximately 2.5595. Now, in this case, my original sine function was rounded to 4 decimal points, or was provided at 4 decimal points. I'm going to provide my new answer to the same number of decimal points as the given information. That's it for reciprocal functions for now. There's more things that you might learn in a different class, but those are the key things that we are going to talk about with regard to reciprocal functions. We are going to, in the trig packet, do one other type of problem that we will talk about when we get to that in class.